All right. What we're going to do is look at this example here, and we're going to figure out what our vertical asymptotes are. That is going to help us find our domain. Then we're going to find our horizontal asymptotes, which will help us find our range. And then we're going to find our y-intercept and our x-intercept. And then also identify if we have any holes. So, looking at this, this is already in factored form. I'm just going to show you what it would look like if we did not have it in factored form. I'd have to distribute the numerator, or sorry, the x that's in that denominator to x times x, which is x squared, minus 5x. So this is what it looks like in standard form, and this is factored form. So sometimes you will have to factor to find the intercepts. For your vertical asymptote, we need to figure out when does the domain not work. So if I look at my graph here, on my x-intercept, what values can I plug in to this function that make it real? And then what values will I plug in that makes this undefined? So for it to be undefined, we know that the numerator can be any number, but the denominator would be 0. So I cannot have this. This cannot happen. So this would be a restriction. So what we do to find our vertical asymptote is we take only the denominator and set it equal to 0, because those values will tell me what x values make it undefined. So our vertical asymptote talks about our x. Okay, so I'm going to take my denominator. I'm going to take the factored form, which is x and x minus 5, and I'm going to set it equal to 0. There's two different factors here, so I'm going to set each of them equal to 0. And then what you need to do is solve for x if you have to. If we look at this one's already set equal to 0. Okay, so my first VA is x equals 0. My second one, I have to add 5, and x equals 5. All right, so that is my second VA. So we have two of them for this example. So we have x equals 0 and x equals 5. So to graph it, you would go to 0, because I know that's my first one, right? So I'm going to draw a vertical dashed line going through 0 for x. And then we have 5. So 1, 2, 3, 4, 5. At that point, I'm going to go do my vertical asymptote. So those tell me I cannot cross these two vertical asymptotes. X is undefined at those 2 points. So my domain is all real except 0 and 5. Now, for the horizontal asymptote, we are going to look at our degrees. So the first scenario is if the top is heavy, then it is going to equal, there's going to be no HA. And then if the bottom is heavier, then it's going to be y equals 0. And if they're the same, then you look at the coefficients. So if we look at the top here, I see that my only exponent is just x, and this one is x squared. This exponent in the numerator is x to the 1 power. So my degree is 1 over a degree of 2. This is bottom heavy. That basically means that the degree in the denominator is bigger. So since the degree is bigger, that means the denominator is going to get a bigger number and the top number is going to get smaller. It's going to stay the same. So as I add a bigger number in for a variable, then this fraction is going to get closer and closer to 0. So my horizontal asymptote is y equals 0. So what I'm going to do is also graph that horizontal asymptote, and it's going to go through when y is 0. You can barely see it just because it's on the y-axis or the x-axis. But those are my horizontal asymptotes, my only horizontal asymptote. All right, so that's the horizontal asymptote. These are my vertical asymptotes. Now, since we found our HA, we know that our range, if you look at this graph as if you're going up and down, if I go up and down here on this y-axis, I see that I can plug any x value above 0 and any x value below 0. So that tells me it's all real, except when y equals 0. All right, I'm going to erase that crap because it looks terrible. No, I didn't want to do that. Oh well. So let's draw a dash line. Okay. Now we have our y-intercept. The y-intercept is much easier than the x-intercept. The y-intercept, all you need to do is replace all of my x values with 0. So x is going to equal 0. So I'm going to take either function. I can use the factored one or the standard form one. I'm going to use the standard form. Honestly, it doesn't matter. So I'm going to have 0 plus 3 over 0 squared minus 5 times 0. We notice here right away that 0 plus 3 is 3. 0 squared cancels out, and so does 5 times 0. So 0 minus 0 is just 0. And we notice 0 is in the denominator, so this is undefined, which tells me that we have no y-intercept for this example. But you don't need to actually do it for this example because we know that our horizontal asymptote is already y equals 0. And we also have an x-intercept of y equals 0. So I can't use 0 in general for my y-intercept for my x, because my x is already 0 for the vertical asymptote. See that? So that's none. Now for the x-intercept, we can set the numerator equal to 0 this time. For an x-intercept, since we actually want a real solution, we can only have a fraction that is 0 over a number. The denominator cannot be 0 because we're not trying to find restrictions, we're trying to find the x-intercept. So for x-intercept, we know it's going to be a number, possibly, comma 0. Y will be 0 this time. So I'm going to take 0 equals my numerator only. And then I can solve this, subtract 3. X is going to equal negative 3. So that tells me I'm going to take that negative 3 and plug it in for x. So my x-intercept is negative 3 comma 0. So we have a point for that value. So if I want to actually graph that, I can go to negative 3 for x. 1, 2, 3. And, well, that should hit the fan right there because I can't really graph on top of this. So that scenario kind of like blew up in our face. But that's how you find intercept in general. Unfortunately, our HA is undefined. So our HA is 0, so I can't actually get that answer. But in general, you can always just do your numerator equals 0, find your x-intercept. The wholes. If I look at this here, I have a factor of, can't write on top of that apparently. I have x plus 3 in the numerator and x, and then x minus 5. I noticed that on the top and bottom, there's no common factor, so I can't cancel anything out. So then that means I have no whole. If the factors are the same, such as, let's say we have x minus 3 over x minus 3, then I could cancel out these two numbers, and my whole would have been 3. My VA would have just been that, whatever that x equals. Okay? If you have any more questions, please let me know. I hope this helps you. I tend to make a little more sense, hopefully, because you're used to my teaching style. But that's it. That's all you need to do for this week. Okay. Oh, video.